Hello and welcome to part 2 of module 20 in our C language series. This session is going to focus on the breadth first search, but before we get down to discussing that, let's do a recap of the depth first search. And if we look at this, of course, in terms of a tree with our starting point being A and our destination being F, as we saw in the last session, our solution path is something like this, where in effect we're starting at A, going down the left subtree until we find a terminal node or the goal. In this case, of course, we find the terminal node. So we back up one level and then we go right and left and right again until we find, of course, the goal or another terminal node, right? So now let's go ahead and discuss the breadth first search. And as you may have already figured out, the breadth first search is the opposite of the depth first search technique, which means in effect that we're going to be searching breadth-wise along the same level before going down to a deeper level. So in terms of a tree, and remember the breadth first search, just like depth first search, is going to look for a solution. If it finds one, it's not going to look any further, right? But looking at the search in terms of a tree now, with our starting point being, for example, A and our destination being C, then this would be our solution path. So in effect, we are starting at A, then going down to B, and then searching breadth-wise, you can see along the same level, and then reaching the goal C, right? So now let's go ahead and modify the program written in the last session so as to use a breadth first search technique instead of the depth first search technique. Origin, of course, is New York, destination is Los Angeles. So let's now go to code blocks, and we need to open that same project. So we click on open, right? And I've landed, as you can see, in the same folder. But as you know, if you're in a folder just above, then look for your project, right? And then click on the CBP file. Now, the changes you have to make in order to implement the breadth first search are in the isFlight function. What we're going to do is we're going to essentially comment out this entire block of code until this point. So we have those opening and closing brackets for the function. And here you can put in a comment indicating this is a depth first search. And then put in another comment at this point indicating this is the breadth first search. Okay. And now, of course, we can put in the code. Right. So we start with a while loop, while, and the condition is while dist equal to, we're calling find connect, looking for a flight between our origin, which is New York, and anywhere. Okay, so as long as this condition is fulfilled, the while loop will continue. Within this loop, we'll have a printf statement first, and this is just for our reference, from %s, right, and then anywhere %s \n, from, anywhere. Okay, again, you can remove this line of code or this printf statement once you've understood how the code works. Then we have an if statement, and within that, we're checking if d is equal to, we're calling find direct, looking for a direct flight now between anywhere and our destination. If we do find the direct flight, we have a printf statement again for our reference, from %s, anywhere %s to %s, and distance or dist, okay, %d \n comma, from, comma, anywhere, comma, to, and dist. Okay. And then we push this root onto the stack. So that will be from, comma, to, comma, dist. Right? And then we will have another printf statement again for our reference. This will print anywhere to and d. That's comma anywhere to and d. And now we're going to push this root also onto the stack. So anywhere to and d. Right, semicolon missing there. And then of course we return. Okay, so I hope you understand how this works. Again, the while loop will continue as long as we find a flight from our origin, that is New York, to anywhere. Right? And every time we find that flight, we'll check if there's a direct flight between anywhere and our destination. If there's no direct flight and we've checked, all possibilities with find connect, then we'll come out of this while loop. And here we will check if dist, and again now we're going to call find connect. So if dist equal to find connect, finding that connection using from and anywhere, right? That is our origin, New York, and anywhere. Then within this if block, just a printf statement for our reference. %d \n, comma, from, comma, anywhere, and dist. Right? And then we push onto the stack the root sending the arguments from, to, and dist. And then of course we need to call isFlight recursively, sending in anywhere and to. Okay, so essentially if you look at this code, it's the same as we used here, right? So we're looking for that connecting flight. Now, if we don't find it, then we need to backtrack. So else if POS is greater than 0, checking for something on the stack to pop, then we'll call the pop function from, to, and ampersand distance, or dist will be the arguments. And then again we use recursion and call isFlight, sending in from and to. And that's all the changes we need to make in the isFlight function. Right? So now let's run this, build it first. Seems to be a spelling mistake somewhere here. That's here. Anywhere. Build again. Right, now run. Put in New York and Los Angeles. And you can see how this while loop is working. Right, so for the first time we find New York to anywhere, that's Chicago, but then we do not have a direct flight between Chicago and Los Angeles. Right, so we go back into the while loop and we find New York to Toronto. Right, and this time we do find a direct flight between Toronto and Los Angeles. Right, and then of course we print out the route and the distance. So I hope that's clear. Again, you can play around with this program after the session. Now moving on. Let's take a look at the solution path we found using the breadth first search technique. So this is of course our tree, that's our origin. We have direct routes to Chicago, Toronto, Denver, and then the via routes to other destinations, including those to Los Angeles. When we examined New York to Chicago, we couldn't find a direct flight Chicago to Los Angeles, and so we examined New York to Toronto. Note how we are searching along the breadth of the tree. We did find a direct flight Toronto to Los Angeles, and that's the first solution we presented, right, using the breadth first search technique. Now let's analyze the breadth first search technique. The good is that in our case, we found that solution, the first solution, without backtracking. The bad would be if the solution or the goal we were looking for lay several layers deep, which would then require considerable effort in order to reach that goal or find the solution. The conclusion, therefore, is that although in our case we did find that good solution, it is not necessary in all situations that the breadth first search would give us a good solution. But just like the depth first search, the breadth first search always guarantees a solution, because remember, it would eventually degenerate into an exhaustive search. And we know from the last session that an exhaustive search involves examining every possibility or every node. But are these methods then good enough to use in an AI program? Which brings us to our discussion on adding heuristics. We could say that both the breadth first search technique and the depth first search technique are blind, because in essence, they start at a particular point looking to reach the goal or the solution, but without any educated guess on the part of the computer. So when we ask the question, could these techniques be used in an AI program? The answer would be no, because AI programs require superior methods which can only be achieved using heuristics. So talking about heuristics now, in the last session I mentioned that heuristics are thinking methods that we as humans use in order to make decisions faster, right? And also to find quick solutions to problems. So in essence, they're a means to an end, the end of course being the goal that we are trying to reach. We may have to work backwards from the goal, trying to chart that path to the solution. In terms of search methods, though, heuristics are rules that qualify the possibility that the search or the search solution is moving in the right direction. So to give you an analogy, if we have hikers lost in the mountains, for example, and the woods are really dense, so they cannot see far, they need a drink of water, what would be the thought processes going through their minds? One would be maybe they need to walk downward, right, towards a valley. Water flows downwards would be the thinking there. They would also look for animal tracks, maybe like deer tracks. The thinking there would be that animals walk to water holes in order to get a drink of water. And so they proceed cautiously down the mountain. Then they hear a kind of a rush to the left of them. So they follow that sound. But remember that it's not guaranteed that they're going to get that water, right? They follow that sound nonetheless. Then they feel the humidity in the air as they get closer to that sound. And finally, they get their drink of water. What they've used are heuristics, but remember that heuristics are neither precise nor are they guaranteed to give you the solution or take you to the goal rather that you're looking for. But there are advantages. What are the advantages? One of the advantages is, of course, that they increase the chances of reaching the goal quickly, right, or speedily, as well as finding the optimum path to that goal. Remember, we spoke about in the last session the factors to consider when evaluating a search solution. And we talked about both speed as well as a good solution. right? In short, heuristics up the odds in favor of attaining quick success. Remember that in terms of heuristics in search methods, they work on maximizing or minimizing some aspect of the problem. So in the next session, when we discuss the hill climbing technique, we look at how we use heuristics and then find a solution using those heuristics, minimizing connections to the destination, right? And later on, we'll talk about the least cost search technique, which will use heuristics, minimizing the miles this time. So this ends our session for today. Till the next session, take care, stay safe. Bye.